Find the Laplace x of s. Obtain this is our model. Okay, so let's do this. With your permission, I'm going to erase this particular panel of the board. Okay, if everybody has got it. So the equation or the ODE is in the time domain. So what I do is I bring it into the Laplace domain by taking Laplace transform on both sides of the ODE. Okay. So Laplace of x double dot 3x dot 2x is equal to Laplace of 0. Laplace of 0 is 0. Okay. We make use of the property of linearity, which means that each and every term can be taken an individual Laplace transform of. So this is Laplace of x double dot 3 times Laplace of x dot 2 times is equal to 0. Do the substitutions. X of 0 is x naught, x dot of 0 is v naught. So Laplace of x double dot is Laplace of d square x by dt square. So the first term becomes s square x of s minus s times x naught. X naught is x at t is equal to 0 minus v naught. Is everybody on board with what I have written here? Are there any questions? I've just directly substituted for x of 0 and x dot of 0. Okay, no, nothing funny or tricky going on. Then 3 times Laplace of that creature is 3 times s x of s. I'm just looking at what I have written here. X of 0 is x naught. Okay, so that's minus x naught. Laplace of x is x of s, capital X of s, is equal to 0. Looks good? Looks good? Looks yes.
Is that 2x of s?
Oh yes, 2. Thank you. I forgot. Yeah. Good catch. Age dims the wits. Okay. Looks good? Now couple all the terms together by taking x of s as a common factor. Okay, so look at this. Combine all the terms containing x of s. So I have an s square, I have a 3s, and I have a 2. Take all the terms that are negative, because we are positive thinking people, throw them on the other side, they become positive. Right? So which means I have an s times x naught minus 3 times x naught minus v naught, bring it on to the other side. So this is now going to be x naught times s plus 3, and I'm going to have a v naught. Say that again, please.
3s minus 3.
No, so I'm bringing this guy to the other side. So all the negatives become positive.
It's positive 3.
But it's combined with a negative x naught. Okay? I'm going to clear this stuff here, the first 2 lines. Okay? I'm going to clear everything, and all of this will be posted, so don't worry if you have not caught it. Put everything together now. So x of s is equal to x naught times s plus 3 divided by, I'm taking it and putting it on the other side, plus v naught by what have I done? I have taken, of course, making things more complicated is our aim, right? So I've taken the ODE, which is in the time domain, brought it onto the Laplace domain. But here, I'll write it in a much more familiar form. Let's, of course, this is the answer we want, but that's not what I want to say today. I want to say something more with the next few minutes. This is the answer that we want. This is where the problem I asked ends. Here is why I'm doing it. For example, say x naught is equal to 0. Just get rid of that. Why not, right? What am I left with? I'm left with b naught by s square plus 3s1. Say that b naught is equal to 1. Then x of s s square plus 3s plus 2. Do you all remember your quadratic formulas? S square plus 3s plus 2. If I make use of the completion of squares, and we will do this in the next class, will give me s plus 1 times s plus 2. Have you solved something like this before? Do you all recall partial fractions? We're going to use partial fractions for some time. Then you're going to see much more complicated problems which will be using MATLAB. Okay? So we use partial fractions. Very last minute, and then you will write this as following: some constant c1 by s plus 1, c2 by s plus 2. You'll obtain c1 and c2 using partial fractions, and here is what you will eventually do. You will take inverse Laplace transforms on all sides. Okay? Very last minute. You can obtain c1 and c2 using partial fractions. If I take inverse Laplace, this becomes x of t. You remember, Laplace of e to the power minus at was 1 by s plus a. So this is essentially c1 times e to the power minus t. And what do you know? I have solved the differential equation without using any other method. Thank you.